require some fundamental concepts. We require some fundamental concepts. So the first topic which we are discussing here is the properties of the cosinusoidal signal. Properties of the cosinusoidal signal. So in this voltage, in this time varying voltage, which is a cos function, how many parameters are present? How many parameters are present? Okay. There are four parameters. There are four parameters. One is the amplitude. This is called amplitude or magnitude. This is the nature of waveform. Just a minute. Nature of waveform. And the third parameter is the frequency. The fourth parameter is phase angle. Phase angle. So in any cosinusoidal signal, either it is voltage or current, there are four properties. One is the amplitude, nature of waveform, frequency, or you can call it as an angular frequency. The other one is the phase angle. The other one is the phase angle. Just give me 30 seconds break. I'll drink water. So out of these four properties, what happens? The two properties do not change when you apply this to any linear network. When you apply this to any linear network, the two properties will not change. The other two properties that will change, the two properties may change. So before going to that, few fundamental things should be clear. We will learn those fundamental things and will proceed. The fundamental things which you should be aware of is, what is RMS value? The second one is, what is a linear network? And what is the phasor? What is the phasor? Okay, these things are very much essential for understanding electrical engineering. Either it is power system, machines, or any other subject. You should have a clear-cut idea of what these values mean. Okay, so it may be a boring, or if but still few of the students may not be aware. So bear with me. Okay, so RMS value, that means it is called a root mean square value. But what is the significance? Why every current we measure, every voltage we measure is an RMS value? Okay, so when you take any cosinusoidal waveform, so this is the nature of the voltage and currents will be in this form. In this form, where this is the peak value. Understand? So what is the average value? Average value of any periodic signal is 0 because it is symmetric about the time axis. So average value is 0. So what is the significance of this RMS value? So suppose if I take a DC network, a DC voltage source, I am applying to some resistor, and similarly I am taking an AC voltage source and I'm applying to the same resistor through switch. Imagine this is one heater which you have immersed in a bucket. Okay, one is a DC heater, the other one is a AC heater. That means one heater is being fed from a AC source, the other heater is being fed from the DC source. Okay, the water in the bucket is identical in both the cases. I am closing both the switches at the same instant of time. That means both the switches I am closing at same time. And After a gap of say 10 minutes or 15 minutes, I am opening both the switches at the same instant. At the same instant. Now, if I measure the final temperature of water in both the buckets, if I get the same value, so what is the conclusion? Both the sources have performed same amount of work, or both the sources has transmitted same amount of heat energy to the identical loads in same time interval. Understand? Very simple. Both the sources have supplied same amount of heat energy to the identical sources in the same uh, time period. In the same time period. That means work done by this source, DC source, is exactly equal to work done by AC source in same time frame. So the power transmitted by this DC source is equal to the power transmitted by this AC source to the same load. So I can treat both the sources. As equivalent. Suppose my DC voltage is say 100 volt. Okay, my AC voltage source is say Vm A cos omega of t plus phi. Let us say this AC voltage is A cos omega t plus phi. Then for this voltage, AC voltage, the effective value, the equivalent value of DC is 100 volt. Equivalent DC value or the effective value is 100 volt. So this 100 volt is called RMS value of this AC source. This 100 volt is called RMS value of this AC source. Understand? In simple language, you can say DC equivalent value of AC source is called RMS value. DC equivalent value of a AC source is called RMS value. Okay, so I have explained this in the experimental format. So both the sources are supplying the same power to the same load. That is the point. So how we can compute this effective value, DC equivalent value? We can compute it by calculating root mean square of AC signal. So that's why the name RMS has come. Mathematically, we can compute the effective DC equivalent value of any AC signal by calculating the root mean square of that value. So that's why it is being called as a RMS value. Sir, how do we calculate root mean square? It's very simple. If it is a periodic signal, first is what? Root. Mean means 1 by time period into 0 to time period into it is, suppose if it is a function of time f of t dt. Square means you square the function. So this is the RMS value of any periodic signal. That is 1 by t into integral 0 to t into f of t whole square dt, where t is the time period of signal. Understand? Okay, so in this way you can calculate the effective value or DC equivalent value of the any signal. So that's why the RMS value is having that much significance. Okay, all the measurements, all our measuring instruments in power system, that means the voltmeters and ammeters, they only measure the RMS value. Understand? So the next point is linear network. What is a linear network? So any network that obeys homogeneity principle and superposition theorem is called a linear network. Homogeneity principle and linear network, superposition theorem is a linear network. To understand in layman's language, suppose this is a system or a network. Suppose if I give A as input, my input is A. For this input, the system is giving B as the output. So for this system, my A is the input, B is the output. So if I multiply my input with any scalar, let us say K, I am multiplying my input with any scalar, K, it may be positive, negative, or zero. Then if my output also gets multiplied with the same scalar, then my system is a homogeneous system. Homogeneous system. That means my system is obeying homogeneity principle. Homogeneity principle. Understand? Only linear system will obey the homogeneity principle. Understand? So it is as simple as that. If two people can cut 4 trees in one day, two people can cut 4 trees in one day. Can anybody tell how 4 people can cut dash trees in 2 days? 4 people can cut dash trees in 2 days. What is the answer? Anyone? What is the answer? $16. Yeah, 16 may be right. Yeah, 16 is right. So here, what you are imagining? You are thinking that all people will work alike with equal sincerity and with equal vigor. Okay. But one fellow may not work. He'll sit idly because other three are working. Let me enjoy. Because human beings is the most complex nonlinear system. But we, right from childhood, by default, the linearity is injected in our mind. Understand? Okay. We imagine that everything works in a linear fashion. So 2 people can cut 4 trees in a day, then 4 people can cut 16 trees in 2 days, assuming that every human being acts in a same way. Some person may be strong, some person may be weak, some person may be very sincere, some person may not be sincere. All these are the non-linear things that comes into picture, but we expect our systems are linear. Understand? That is the homogeneity system. By default, homogeneous, you're assuming that the things are homogeneous, things are linear. I'm sorry, that's why you have told the 16 as the answer. Okay. The second point is superposition theorem. Suppose for the same system, if I give x as the input, I am getting my output as y. For the same system, my input is x and my output is, for input x, my output is y. Suppose for the same system, if I give ten into x plus a as my input, 10 into x plus a as my input, if my output is 10 into y plus b, then my system is obeying homogeneous as well as superposition principle. Superposition principle. Understand? Homogeneous as well as superposition principle. Because it is obeying. That means if you add both the inputs, even your output should also be additive in nature. Then it is obeying superposition principle. So any network, any system that obeys these two laws is called a linear system. Is called a linear system. So how we understand linearity in terms of electrical systems? How we understand it? So here, if I take a simple resistor, say 10 ohm, this is 10 volt. What is the current that flows here? 1 ampere. 1 ampere. Understand? Suppose if I multiply with 10, then what is my response? My response current also gets multiplied with 10. Understand? So in this case, what will be the current flowing? 10. Suppose if I multiply again with 10, then my response, I am assuming it is also getting multiplied with 10. Okay. So you are assuming that this resistor can accommodate or can dissipate whatever power that is supplied to it. That is called an ideal resistor. An ideal resistor. But practically what happens, once you supply 10 amperes, or once you supply more than 30 or 40 amperes, depending upon the heat dissipation capacity of that resistor, the resistor will burn. The resistor will burn. But what you are assuming? You are assuming this resistor is ideal. It is having infinite capacity to dissipate power. So you are modeling it as a linear element. You are modeling it as a linear element. So all the elements, what are the major elements? Resistors, inductors, and capacitors. We are assuming them as a linear. We are modeling them as a linear elements. Understand? So electrical power system mainly consists of resistors, inductors, and capacitors, and we are assuming that all these parameters which we are assuming are linear in nature. So that's why our power system network is a linear network. Linear network. Understand? That is about the linearity which I want to explain. So blindly you remember one thing. If your network contains only resistors, inductors, and capacitors, then your network is a linear network. Your network is a linear network. Understand? The next concept is concept of phasors. Concept of phasors. Do you want a break? So usually what is the time for which they give break, gentlemen? 5 minutes. Okay, you can take 5 minutes break. Uh, you can take 5 minutes break and we will continue the session. Are you writing notes? Anyhow, I'll be sharing this PPT in PDF format. Main points, I always suggest you to note down. What are the points in the PPT that you can fill? You can keep some gap and you can fill. The PPT which I am explaining you, I'll share it to you in the PDF format. So we are discussing the concept of phasor. Okay. Now, for any linear network, suppose this is a linear network. Just listen this concept like a story. Okay. Just we need the crux only, but still I am telling you, as you're all electrical engineers. So for this linear network, I am exciting or I am supplying some voltage. Okay. And in this particular resistor, I'm interested in the response. Okay. So here I'm applying a voltage, say V of t is equals to Vm cos omega t plus theta. I'm applying this voltage to it. And this linear network contains many linear elements like resistors, inductors, and capacitors in different combination. I don't know what is that, but I'm only interested in response across this resistor. Okay, say R1. Here the current which I'm getting is, say, I of t is equals to Im cos omega t plus phi. Plus phi is the current. Okay, so for this excitation, I am getting this response. I'm getting this response. Okay, so every time, suppose if my input, if I change my input to, say, V dash of t, that is equals to Vm sine of omega t plus theta, then my response, say, let us call this I dash of t, will become how much? Im sine of omega of t plus phi. So in the first case, my input is Vm cos omega t plus theta, and my response is Im cos omega t plus phi. In the second case, my input is Vm sin omega t plus theta. My response is Im sin omega t plus phi. Okay. Now, for the second input, if I multiply with a scalar, if I multiply with a scalar called j, I'm multiplying the signal with a scalar constant j. Then my response, because since it is a linear network, it should obey homogeneity principle. My response also gets multiplied with the j. Okay. Now I am applying superposition theorem. That means I am putting both these as the input. That means now my input is, now my overall input to this linear network is Vm cos omega t plus theta plus j into Vm sin omega t plus theta. This is my input to this linear network, which contain all linear elements. Then my response would become how much? This will give the response of Im cos omega t plus phi plus j into Im sin omega t plus phi. Okay. So this is the input, this is the excitation, and this is the response. So from mathematics, if you remember your Euler's theorem is a e power j theta. A e power j theta, I can write it as a cos theta plus j into a sin theta. If you know this one, you can write in this fashion. This is called exponential form. This is called exponential form. This is called rectangular form. This is called rectangular form. I hope you remember your 10+2 mathematics. Understand? So now, if you can carefully observe this, my excitation and my response are in which form? They are in the form of the Euler's theorem, rectangular form. I can write them in the exponential form as Vm e power j theta, Vm e power j theta, sorry, yeah, Em e power j omega t plus theta is my excitation in exponential form. This will give a response of Im e power j omega t plus phi. Omega t plus phi. Understand? Now, if I can split this into two parts, it will become Vm into e power j omega t into e power j theta. This one will become Im into e power j omega t into e power j theta. Understand? So in every term, where you are applying the cosinusoidal signal, this e power j omega t term is common. By default, it will come. By default, it will come. By default, it will come. So I know that every term contains this e power j omega t. Any voltage and any current contains this e power j omega t term. So I am knowingly omitting this one. I am knowingly omitting. That means I am not writing it every time. I'm just omitting. I know that it is there. I know that it is there. Okay. So now what will be happens? So this will become Vm into e power j theta, which is giving Im e power j phi. J phi. Understand? So the same thing I can write it as. I can write it as. How you can write e power j theta? E power j theta will become, this a will be going, e power j theta is nothing but cos theta plus j sin theta. That means cos theta plus j sin theta value is how much? You can also write this as magnitude is 1. The magnitude of this one is 1. What is the angle? It is tan inverse. I mean, the angle will be sin theta divided by cos theta. You're going to get the angle as theta. This particular form is called polar form. This is called polar form. This is called rectangular form. This is called exponential form. Exponential form of the complex number. Usually this discussion comes in the complex number. Here also we are encountering such a similar representation. I can write this one as this as Vm at an angle theta is my excitation, which is giving a response of Im at an angle phi. Im at an angle phi. Okay. So here this Vm at an angle theta contains this. I need an empty slide. Let me go back. Yeah. This Vm at an angle theta is our excitation. It is giving a response of Im at an angle phi. Okay. So this form of representation is called phasor form. Understand? Okay. So any cosinusoidal signal, you're bringing down it to phasor form. Why? Because dealing the phasors is very easy. The second most important thing which you have to remember is how different are phasors from the polar numbers. Sir, are the polar numbers, that means what is a polar number? If suppose somebody writes 4 plus j3, some x is equals to 4 plus j3. How you can write it in polar form? The magnitude of this is square root of 4 square plus 3 square. It is 5. And the angle of this one is tan inverse 3 by 4, which is 36.86 degrees. You can write this one as so much value. This is a polar number, polar form. This is a polar form of x. So similarly, when I write a voltage 10 root 2 cos omega t plus 30 degrees, this is a voltage signal V of t. I am writing this in the phasor form as I am only taking the magnitude, that is 10 root 2, and what is the phase angle? 30 degrees. I use the symbol capital. We don't write it as a time. It is capital. Are these two same? Are these two same? This is called phasor. This is called polar. They are different. They are different. Sir, why sir they are different? Why? Because in every phasor there is e power j omega t term which we have omitted. Whereas there is no such term in the polar numbers. There is no such term in the polar numbers, but every phasor contains a term which is e power j omega t. So that's why there is one more term that is coined, that is called phasor. Phasor. Why? Because there is e power j omega t term. What is the significance of this e power j omega t term? I'll tell in the next 5 minutes. But you remember, polar is different from phasor. Why? Because it is having some other additional term of e power j omega t. Second, that is one point. Second point, sir, in the discussion, sorry, in the discussion you have taken some imaginary term. That means what I have clubbed? I have clubbed real term with some imaginary terms of 10 root 2 sine omega t plus 30. I have intentionally added some imaginary term to my real voltage. Are there imaginary voltages and currents? No, there are no imaginary voltages and currents. So this term does not exist. This term does not exist. Just to bring down my time domain signal into phasor form, I have done some mathematical jugglery. I have done some mathematical jugglery. Why? Because time domain analysis is very difficult. It will yield us integral differential equations which are very difficult to handle. Whereas in phasor form, those equations will come into simple algebraic equations. Algebraic equations. Understand? That's why I am doing this mathematical jugglery to bring down my voltages and currents into a convenient form where I can apply my mathematics, where I can do my calculations in a simpler fashion. Okay, so one more thing is inherent which is not mentioned is, whenever you write a voltage, you always have to write real term, real part of 10 root 2 at an angle 30. So since there are no imaginary voltages, by default we know that we only deal with the real values. We only deal with the real values. So we also don't write this term every time. We also don't write this term. So two things knowingly we are omitting in the phasor representation. One is e power j omega t term, which is present in every phasor. The other one is we are only considering the real portion of our voltage or current. So these two internal concepts which you have to remember. Okay. So once you know that inherently there is one e power j omega t term, and we are only considering the real portion of that signal, you can easily convert your time domain signal into phasor domain. What you have to do, you simply have to take the magnitude and take the angle. Take the angle. That is the point. That is the point. So anybody having any doubt in this one, you ask. So far you are, if you are able to follow, well and good. If you are having any doubt, you can ask me. Even if you don't understand, you remember that the procedure to convert the time domain voltage and current into phasor domain. You are taking the magnitude and you are taking the angle. Why we are taking and how this has we have reached, I have just explained little briefly. So gentlemen, any query in this portion which we have discussed? It is completely just mathematical, so that you know that why phasors have come. Any doubt in that? Can I continue? Okay. Yeah. Now, let us understand. I'm taking a time domain signal. Okay. Yeah. Okay, bear with me, it is a cos signal. Let me assume it is a 10 and this is omega t I have written. So this signal will become what? Can anybody tell? Let us assume it is a voltage signal. This signal V of t will become 10 cos omega of t because it is starting at the 0 degrees. Okay, 10 cos omega of t. Now, in polar form, in polar form, in complex domain or phasor domain, how you will write this 10 cos omega of t? 10 cos omega of t, you will write it as 10 at an angle 0. The phasor representation is 10 at an angle 0. Okay. Now, when you draw it in the phasor domain, which is it is a real axis, it is the imaginary axis or j axis, negative of real axis, negative of imaginary axis. Now, if you see, gentlemen, how you draw 10 at an angle 0 in phasor domain? This magnitude is 10 and angle is 0. So this is my phasor V is equals to 10 at an angle 0. This is how you represent in the phasor domain. Now, what happens? So what is the value of the signal when omega of t equal to 0? The instantaneous value of this voltage signal when omega of t equal to 0 is how much? 10. 10. So once it has moved from this value to say some 45 degrees, it has moved. So what is its value? Its instantaneous value is this one, whose value will be 10 by root 2. That means when this phasor rotates in anti-clockwise direction by an angle 45 degrees, how this phasor will look? This phasor will look like this. It has rotated 45 degrees in the anti-clockwise direction or counterclockwise direction. Now, can you tell me what is its real value? The real axis value will not be 10. It will be less than 10. What is its value? 10 cos 45. 10 cos 45. So this 10 cos 45 is exactly matching with the real axis value, the instantaneous value in time domain. Okay. Now, when this time domain signal comes to 90 degrees, what is the instantaneous value of this voltage when omega t equal to 90 degrees? What is the instantaneous value? 0. So, when this phasor rotates in anti-clockwise direction till this 90 degrees, now can anybody tell me what is the real axis value? The real value of this one is 0. The real value of this one is 0. So here when it is at 0 degrees, the real value is 10. The real value is 10. Imaginary value is 0. When it is at 45 degrees, the real value is 10 by root 2, which is matching with the instantaneous value. When it shifted 90 degrees, the instantaneous value is 0 and here the real value is 0. Similarly, likewise, when you make the rotation complete, that is when it reaches 180 degrees, when this phasor reaches 180 degrees, what is the real value? 0. When it reaches 270 degrees, what is the real value? Real value is 0. 180 degrees, its value is minus 10. I'm sorry, minus 10. So when it shifts 180 degrees, at 180 degrees, its instantaneous value is minus 10. Okay. So here what point which I want to tell you is that the propagation of this time domain signal for one time period, the propagation of this time domain signal in one time period is equal to rotation, one single rotation in phasor domain. One single rotation in phasor domain. So in time domain, it is changing with respect to time. So one time period in time domain is equal to one rotation in anti-clockwise direction in phasor domain. So your phasor, your voltage or current phasor is not a fixed quantity. It is continuously rotating in counterclockwise direction. At what speed? At omega radians per second. At omega radians per second. That is the mathematical significance of that e power j omega t term. E power j omega t. So this e power j omega t term specifies that your voltage phasor is continuously rotating in counterclockwise direction with omega radians per second. And your phasor diagram, which you are drawing for any voltage or current, is the value of that rotating quantity at t equal to 0. At t equal to 0. That is, phasor is nothing but the snapshot which you are taking of this continuously rotating voltage and current in the frequency domain at t equal to 0. Understand? So that is the correlation between the time domain to the frequency domain or phasor domain. Here it is the voltage or current is propagating with respect to time. Here in phasor domain, it is rotating in anti-clockwise direction with omega radians per second. So whatever phasor diagram you are drawing, that is the snapshot of the voltage and currents at t equal to 0. At t equal to 0. That is the physical correlation between these two quantities. Understand? So you always remember here also the instantaneous values are matching with only real values of that phasor quantity. So we don't consider the imaginary values. We only consider the real values of the phasor, because the real values at a particular instant will match with the instantaneous value of the voltage in the time domain. Understand? So that is the concept of phasor. Yes, even though it's very important for electrical engineer to know the concept of phasor. Why phasors have come? Why RMS value has come like this? Because inherently we don't know, we take things for granted. But if when we encounter in interview or any other practical situation, we will not be able to correlate the things. So the point is, when a linear network is excited by a cosinusoidal source, that means cos source, by a cosinusoidal source, cos or sine. Cosinusoidal means you can take either cos source or sinusoidal source. The response in any branch, the response may be voltage drop, or it can be current through that branch, retains two properties of the waveform. What are the two properties that it retains? It retains the frequency. Frequency will not change, and the nature of waveform will not change. Cos signal will remain cos signal. Omega will remain omega only. There is no change in the nature of signal, and there is no change in the frequency of the signal. But what two parameters it can change? It can change the magnitude, and phase angle can change. Magnitude and phase angle can change. Understand? So for a linear network, if you excite by a sinusoidal or cosinusoidal voltage or current, the response in any of the branches, that means the response can be voltage drop across the branch or current through the branch, those responses will have two properties which are identical to the excitation, that are nature of the signal will not change and frequency will not change. The two parameters that can change are the amplitude or the phase angle. Phase angle. Understand? So what is a phasor? A phasor is a rotating polar quantity. What is the difference? Polar quantity is a fixed quantity, whereas phasor quantity is a rotating in anti-clockwise direction with omega radians per second. That's why in any phasor diagram you have to show that an arrow mark in counterclockwise direction, and you have to write omega. Then only the phasor diagram description is complete. Understand? So a phasor diagram is the screenshot taken of the rotating polar quantities at t equal to 0. So whatever phasor diagrams you're drawing in circuits, in machines, or even in power systems, they are nothing but the screenshots of the quantities taken at t equal to 0. Understand? Gentlemen, this is the backdrop of the phasor. Okay. Now, any doubt in this concept? Any doubt, gentlemen? Okay, thank you. We will just now, whether you have understood or not, remember the table which we are discussing now. That is the crux of what we have discussed so far. Okay. So time domain to frequency domain conversion. Let me draw the difference. Okay. So in time domain, suppose my voltage is V of t is equals to Vm cos omega t plus theta. So how you draw it in frequency or phasor domain? What is this one? Vm at an angle theta. This is the phasor representation. And for phasor representation, we use capital letters, capital symbols. For time domain signals, always remember, for any time varying signal, the notations will be small letters. Even if they don't mention v of t by default, if you are telling a quantity, it is a function of time. Capital V, it will become Vm at an angle theta. Okay. Similarly, I of t is equals to Im cos of omega t minus phi. So what will be the phasor representation for this? We'll write capital I is equals to Im at an angle minus phi. This is so many volt and this is so many ampere. Okay. So in these two cases, we have represented the actual phasors. Actual phasors. But we don't deal with actual phasors. We deal with something called as RMS phasors. RMS phasor quantities. RMS phasor quantities. What is the difference between the actual phasor and RMS phasor quantity? You simply have to divide the amplitude by root 2. You simply have to divide the amplitude by root 2. Understand? So the phasor quantity which we deal in power system are RMS phasor quantity, where the actual amplitude is divided by root 2 or scaled by factor of 1 by root 2. Now let us take some real examples and try to understand it. Let me take that V1 of t is equals to 10 root 2 cos omega of t plus 45 degrees. This is the actual time domain voltage. So if you convert this into phasor quantity, this will become capital V1 is equals to, now since I am writing an RMS phasor, this amplitude I have to divide with root 2 and represent. So it becomes 10 at an angle 45 degrees. So many volt. Okay. Now second example is, let me take some current. I1 of t is equals to 2 cos omega t minus 90 degrees. So many ampere. 2 cos omega t minus 90 degrees. So here it will become I1 is equals to root 2, because we have to divide the magnitude with by root 2, it will become root 2 at an angle minus 90 degrees, so many ampere. Now I have a third one. I want someone to tell me what is an exact phasor value. Yeah, you can unmute and tell me. V2 of t is equals to 10 root 2 sine omega t minus 45, so many volt. So how I can write my V2 is equals to what? What is the phasor value for this time domain signal? Just someone can speak and tell me, because I know it is difficult to type. Anyone?
10 angle minus 45.
Wrong. No.
Minus 10 angle 45.
No. Minus 10 angle will contemplate for this one. See, the thing which you have to understand is that your reference is cos. The first thing which you have to do is you have to again convert it into cos. You have to convert it into cos. So to convert this into cos, what you have to do? 10 root 2 into cos of omega t minus 45 degrees minus 90. So many volts. So many volts. So it will become 10 at an angle minus 135. Understood? Because suppose instead of in this question had I written 10 root 2 sine omega t plus 45, you will be confused. This signal and this signal cannot have same phasor, isn't it? So the reference for any phasor is cos. Remember this golden rule. The reference for any phasor is cos. If sine is given, first you have to convert it into cos and then tell the phase angle. Then you have to tell the phase angle. That is very, very important point. The reference is the cos. Understand? So the next is so continuing the same discussion. Yeah. V3 of t is equals to minus 10 by root 2 into sine of omega t plus 90. Can someone tell me what is the phasor value? Capital V3 is equals to yes, minus 5 at an angle 0. Minus 5 at an angle 0. Understand? Because I am scaling with this root 2, I have to convert this into cos. Cos will become, I have to again subtract 90. So it will become cos omega t. So it will become minus 5 at an angle 0. So many volt. Understand? So R ohms resistance, how it will become? It will become same R ohm. Even in time domain, frequency domain, the resistor will not change its value because resistance is independent of frequency of the excitation. L Henry inductance will become how much? So inductance will become how much? it will become x is equals to jx, it will become, or you can write z, inductive impedance will become j omega L, that is jxl. Understand? In this form, you can write it as xl at an angle 90 degrees. xl at an angle 90 degrees. So many ohm. So many ohm. Understand? Inductance will take the form of j omega L. Even in Laplace transform, it is nothing but the Laplace transform. Why we are not going for Laplace transforms? In Laplace transforms, you have to remember two conversions. First, you have to change from time domain to frequency domain, Laplace domain, and again from Laplace domain to time domain. It is headache process. That's why phasors are the shortcut of the Laplace transforms. Here we need not do any conversions. You will directly get the answers, and it is very easy to convert from time domain to phasor domain. Similarly, C farad will become C farad. So many farads, it will become what? ZC will become minus j omega C, that is minus jxc, or xc at an angle 90 degrees. Xc at an angle minus 90 degree ohm. Why it is becoming? Because when you do Laplace transform, you're getting SL, you're getting 1 by SC. So what is the value of S? S is equals to j omega. 1 by S, it will become 1 by j omega C. So I have done it a little mistake. It is 1 by j omega C, which will become minus j by omega C. Understand? So this is how your R, L, and C will change from time domain to the phasor domain or frequency domain. Resistance will remain same. Your L will become j omega L. Your C will become minus j by omega C. Most common mistake which students do is, if I ask XL, many people will write j omega L, which is a blunder. Which is a blunder. You remember, gentlemen, XL only means omega into L, so many ohms. So if there is JXL, then j omega L is a right option. Okay. And XC is equals to, it is simply 1 by omega C. Minus JXC means minus j by omega C, so many ohms. Okay. Don't ever write XL equal to j omega L. It is mistake. XL is not equals to j omega L, but it is equals to omega L. Similarly, XC is not equals to minus j by omega C. It is equals to 1 by omega C. Okay. This is the few things which you have to fundamentally know when you are entering into any electrical subject. Any electrical subject. Okay. Next. Z is equals to 4 plus J3 ohm. V is equals to 5 at an angle minus 36 plus 5 at an angle 36.86 volt. What is Z and what is V? Option A. Both are polars. Z is polar. V is phasor. Option C. Z is phasor. V is polar. Option D, none. Tell me which is the right option. Or you can do both are phasors. Both are phasor quantities or phasors. Yeah, I need an answer, gentlemen. Anyone? capital Z, which is an impedance 4 plus J3 ohm, and which is capital V 5 at an angle 36.86 degree volt. He has given two. He has told that both are polars, both are phasors. Z is phasor, V is polar, and the ulta one, which is the right option. Anyone?
Sir, chat box we have replied.
Pardon? Okay, chart box we have typed. Okay, okay. Z is a polar, P is a phasor is the right option, which is a right option. Why? Because when you represent Z, it is simply a number 4 plus J3. Real part is 4, imaginary part is 3. So this is the representation of Z. Whereas even though our phasor diagram is the same thing, but it is not a fixed quantity, it is continuously rotating at omega radians. So this is the representation of V and this is the representation of Z. Even though the snapshots look same, this is a fixed quantity. Z is a fixed quantity in complex domain. It will not move anywhere. Whereas this fellow is continuously rotating in anti-clockwise direction with omega radians per second. So voltage is a phasor, impedance is a polar quantity. Okay. So these are few fundamentals which you need to know. So next we'll enter into the single phase transmission that will start in the tomorrow's class. Okay, gentlemen. Thank you.